Good good morning, teacher. And in this video, I'm going to talk about the mobile robot. I'm Hector Gabriel Dominguez from the sex of mechatronic, and that's my presentation. Introduction. Today, the most competitive products combine mechanical, electrical, and software subsystems and components and should therefore be referred to as mechatronic products. The product development process of mechatronic products is characterized by numerous interfaces, cross-domain functions, and high complexity. The planning, execution, and controlling of such process requires elaborate strategies, methods, and tools. This combination, which was developed over the last 2 years, the Hochschule Ravensburg-Weingarten takes into account technical aspects but also the aspects of process planning, execution, and control. Therefore, the term mechatronic engineer was chosen to describe this approach. Mechatronics engineer. Mechatronics is commonly understood as a domain of technological science, which contains the following knowledge fields: mechanical engineering, software engineering, electronical engineering, automation, and robotics. The term mechatronic engineer as analogy to system engineer also focuses on the organizational and process-oriented aspect of the development of mechatronic products. B-model. Nowadays, the B-model has become a standard process model for mechatronic system development. In many industrial companies, generally, the B-model can be divided into three main sections and is always described in B shape. It consists of the system designs. At the left side, the system integration, at the right side, the domain specific design at the tail of the B-model. The figure number 1 shows the general structure of B-model. The B-model, the BDI 2020 2006 has recommended the usage of the B-model as a generic producer. For designing mechatronic systems, it's important to note that even of the macro level in B-model does not necessarily represent the whole development process. On the contrary, a complete development process might consist of several runs of the B-model with increasing product monitoring. This characteristic is highlighted in figure number 2. Similarly, also in system engineering phase, such as preliminary study, main study, and detailed study are proposed, which all trade with the same system, but on different levels of refinement and detail, or experience in the project, and the similar adjacent projects underlines the cycle nature of mechatronic design. It is helpful to understand the most abstract phases of the project plan as cycles through B-models. Figure number 3 shows a possible combination of a project plan, upper plan, and process map. It is important to note that such a direct combination is not always requirement prototypes, degree or maturing degrees of maturity. Access sensible as intermediate milestones might be necessary for controlling the development process of a mechatronic product. Conclusions. The application example of the paper is an innovative design of a well-driven mobile robot chassis. This solution is based on 4 identical driving models with fully rotating vertical axis equipped with absolute position, encoder, and optional electromagnetic brakes, intended to improve the controllability of the axles, while movements are directly obtained from motor equipped with embedded position encoder. Such a designs allow a variety of maneuvers, increase flexibility, and decrease mechanical complexity of the robots. The main advantage of this robot is the superior maneuverability. The second main advantage is the possibility to control the inclination of the robot platform. And that's all. And thanks for your attention. And see you later.